Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Kip Thorne, the physicist who bridged science, cinema, and the cosmos. You know, there's a physicist who didn't just sit behind a blackboard solving equations, he's also saved the universe on the big screen. Sounds like something straight out of a movie, right? But trust me, the real story is even better than anything Hollywood could dream up. This physicist's name? Kip Thorne. He didn't just make black holes, these mysterious, dark holes in space. No, he made them shine. And that's not science fiction, it's real life. Kip was the science advisor for Interstellar, making sure the black holes on screen were scientifically accurate. But he didn't stop there, he helped director Christopher Nolan make the black holes come to life in a way that no one had seen before. And if you think gravitational waves are just some theoretical idea, then you really don't know just how amazing Kip is. He's the guy who made it possible for us to actually hear the sound of the universe. Back in 2015, the LIGO experiment made history by detecting gravitational waves for the first time. That breakthrough? It confirmed Kip's theories. The discovery of gravitational waves completely changed how we view the universe. But Kip's contributions didn't stop with black holes and gravitational waves. He's also studied quantum physics and cosmology, unveiling the mysteries of warped spacetime, and helping us understand how light gets swallowed up by black holes. Kip's not just a physicist. He's a master at explaining science to the public. He's brilliant at making complicated physics concepts both exciting and understandable. And his teamwork with other scientists is something to admire. Science isn't just his job, it's his life. He approaches both his research and his relationships with incredible passion. He's far from being the typical lab rat. Instead, think of him as the rock star of the science world. Movies, lectures, research, he's got it all covered. Kip's life is a journey that blends the academic with the artistic. From black holes to the big screen, he's made the universe feel closer and more accessible than ever before. His story isn't just about academic achievement, it's about how science and art can merge to create something truly extraordinary. Kip Thorne's journey began on June 1, 1940, in Winchester, California, a quiet little town where no one could have guessed that a future giant in the world of physics was being born. His father, Donald, was an engineer, and his mother, a high school teacher. Together, they fostered a home filled with scientific curiosity. As a kid, Kip wasn't like other children who focused on toys. No, he was fascinated by the night sky, gravity, and the speed of light. He would often gaze up at the stars, wondering about the mysteries of the universe. But for Kip, the stars weren't just beautiful, they were puzzles waiting to be solved. He once remembered his childhood thoughts: if light gets sucked into a black hole, where does it go? At that point, Kip didn't dream of being a superhero. Instead, he wanted to be a physics superhero, someone who could unlock the secrets of the universe and black holes. His parents supported every step of his intellectual journey, though they sometimes found his questions a bit much. Kip always asked these questions that left us scratching our heads. His mom once said, like, "Mom, if light can be sucked into a black hole, will it ever come back?" I really wish I could give him a simple answer. But Kip's curiosity was undeterred. In 1958, he entered the prestigious California Institute of Technology, Caltech, where he began his formal education in physics. Here, he met the most influential mentor of his life, the renowned physicist John Archibald Wheeler. Kip's path wasn't easy. He wasn't the typical student who just buried himself in textbooks. Instead, he was the one staying after class to passionately discuss quantum mechanics and cosmology with his peers. At Caltech, he delved into fields like general relativity, astrophysics, and quantum mechanics, and his fascination with black holes deepened. In 1965, Kip earned his PhD from Princeton University, where he wrote his dissertation on the stability of black holes. This research laid the foundation for later developments in black hole physics and provided a crucial theoretical background for his later work on gravitational waves. At Princeton, Kip had profound insights into black holes, quantum gravity, and the curvature of spacetime. His collaboration with Wheeler solidified his commitment to making significant contributions to physics. Kip's time at Princeton wasn't just about intellectual achievements, it was also filled with late-night sessions, deep in thought, as he wrestled with complex theories. Sometimes, he didn't stop working until 2 a.m. But even with all the academic progress, he never lost touch with the warmth of his family. His mother always encouraged him with words like, "No matter what you become, the most important thing is to stay curious and never stop asking questions." Interestingly, Kip wasn't just a bookworm. His parents used to joke that Kip wasn't just a kid who loved reading, his mind bounced around like a little rocket. He was passionate about physics, sure, but he also had a deep love for music and literature. In the early 1960s, Kip continued his research at Caltech, where he and other physicists tackled the singularity problem in black holes. By 1966, Kip co-authored a groundbreaking paper on black holes, proposing the theory of black hole evaporation, later forming the foundation for what we now call Hawking radiation. This theory wasn't widely accepted at the time, but it paved the way for one of the most shocking discoveries in physics. During this period, Kip's research expanded beyond black holes into the early theories of gravitational waves and cosmology. In 1969, Kip and other physicists laid the theoretical groundwork for gravitational waves, setting the stage for their eventual detection decades later. Through it all, Kip's family was his anchor. His mother, in particular, always believed that Kip's unique way of thinking was the key to his success. Kip's always been someone driven by curiosity. He doesn't just accept knowledge, he figures out how to understand the world on his terms, she once said. During his time at Caltech, Kip didn't just develop a profound understanding of physics, he also forged lasting friendships with fellow geniuses. His work with Wheeler was particularly pivotal, as their discussions were more than just theoretical debates, they were intellectual explosions. These years marked Kip's transition from a simple physicist to a multidisciplinary thinker. He wasn't just after scientific truth, he was also on a path to making complex science accessible to the public. Kip's early life was filled with a love for science, the warmth of family, and an insatiable thirst for exploration. Every step he took seemed like it was one step closer to unraveling the mysteries of the universe. But those small steps led him to become one of the giants in the field of astrophysics. In 1965, Kip Thorne earned his PhD from Princeton University. His dissertation, titled The Stability of Black Holes, marked the beginning of his career, focusing on the stability and dynamic behavior of black holes. His work immediately gained attention in the academic world and laid the foundation for much of the research that followed. At Princeton, Kip was introduced to his mentor, John Wheeler, one of the pioneers of general relativity. Wheeler wasn't just Kip's teacher, he was also the one who helped ignite his interest in the experimental side of black hole physics. Wheeler believed that black holes were more than just astronomical phenomena, they were objects that could influence surrounding matter and space. Kip and Wheeler's collaboration led to theoretical breakthroughs, including the concept of a black hole singularity, a point in the center of a black hole where density becomes infinite, and the laws of physics seem to break down. This idea became one of the most challenging problems in physics. By 1967, Kip was exploring the black hole information paradox, which questioned whether black holes could store the matter and information that passed through them. Some believed that information disappeared forever, but Kip argued that it wasn't lost, it existed in some form. This issue remains unsolved to this day. Kip's theoretical work on black hole evaporation was groundbreaking. In 1974, Stephen Hawking proposed Hawking radiation, suggesting that black holes emit radiation and slowly lose mass. This theory aligned closely with Kip's earlier ideas, and together, their work challenged the notion that black holes only consume matter. Kip believed that black holes were not just cosmic monsters that devoured everything in their path. They were, in fact, active celestial bodies with immense influence over the space around them. Their intense warping of spacetime made them some of the most powerful and mysterious objects in the universe. Kip also made significant contributions to understanding how black holes affect the curvature of spacetime. In his theory, black holes could slow down time itself, and near a black hole, time could nearly come to a halt. This work had profound implications for our understanding of how the universe operates. By the early 1970s, Kip had begun collaborating with other scientists like Rainer Weiss and Barry Barish to develop the theoretical framework for gravitational waves. These ripples in spacetime, generated by the movement of massive objects, would later be detected by LIGO. Despite being a cutting-edge theoretical field, Kip's work laid the foundation for the eventual detection of gravitational waves. He also focused on observational techniques, collaborating with astronomers to develop methods for detecting black holes. In 1980, Kip was already a leading figure in physics, not only making groundbreaking contributions to black hole and gravitational wave research but also bringing these concepts to a global audience. His work helped the public understand the complex phenomena of the universe, and he became a pioneer in science communication. Kip's influence extended beyond academia and began to impact society at large. While black holes were still considered mysterious dream toys to many, Kip proved that they weren't just theoretical objects, they were key to unlocking the mysteries of the universe. His work on black holes, gravitational waves, and general relativity opened up new avenues of exploration and provided essential clues about spacetime, gravity, and the structure of the universe. Kip Thorne's contributions helped take black holes from the fringes of theoretical physics to the mainstream of science. But Kip's contributions didn't end with black holes. His research touched on many areas, including cosmology and quantum gravity, helping to deepen our understanding of the universe. Kip Thorne is a true explorer of the cosmos and a pioneering force in science, whose career has helped reveal some of the deepest secrets of the universe. In the early 1990s, Kip Thorne took on an ambitious new project, one that would change the way we understand the universe, LIGO. LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, was designed to detect gravitational waves ripples in spacetime that come from the most violent and energetic events in the universe. This wasn't just a typical astronomy project. No, this was a revolutionary challenge. You see, back in 1915, Albert Einstein predicted the existence of gravitational waves. But for decades, they were considered little more than a scientific fantasy. The waves were so weak, so minuscule, that detecting them with any existing technology seemed impossible. But Kip, ever the visionary, wasn't deterred. He wasn't just a theorist, he was at the forefront of making that fantasy a reality. While others doubted, Kip and his team fought to build a machine that could actually measure these tiny ripples. And in doing so, they combined mind-bending concepts like black holes and spacetime curvature with cutting-edge technology in what felt like a race against time itself. Imagine, for a moment, that decades later, we'd realize LIGO was essentially the ears of Earth listening for the faintest whispers of the cosmos. And Kip Thorne was the detective, the one guiding the team, overcoming setback after setback, inching closer to unlocking the universe's deepest mysteries. But LIGO wasn't an easy road. In the beginning, many people were skeptical about the project's feasibility. Gravitational waves are incredibly faint, so faint that they were often drowned out by the noise of Earth itself. And to make matters worse, funding wasn't immediately available. Kip and his team had to pitch the project worldwide, constantly seeking investors to keep the dream alive. But it wasn't just about securing funds. The real struggle was turning theory into practice. The technology didn't exist to measure these waves, so they had to build it from scratch. Even the first designs of the detectors faced challenges with precision and stability. But Kip wasn't a man to give up. He persisted, leading his team through failure after failure. Gradually, as technology advanced, LIGO started to take shape. By 1999, two of LIGO's main facilities, one in Washington state and another in Louisiana, were up and running, using massive laser interferometers to measure tiny shifts in space itself. Despite all this progress, the gravitational waves still didn't appear. The team was under immense pressure. But Kip never lost faith. He would often say, "Science is all about pushing boundaries. You keep testing the unknown, and eventually, you'll make breakthroughs that no one thought possible." And then, on September 14, 2015, their perseverance paid off. LIGO detected gravitational waves for the first time. This wasn't just a win for Kip and his team, it was a victory for the entire world of physics. The detection confirmed Einstein's century-old prediction and ushered in a new era of astronomy. For Kip and his team, this was the culmination of a lifetime of work. The discovery was the shared achievement of Kip, Rainer Weiss, and Barry Barish, the trio whose dedication made LEGO's success possible. Their work not only brought gravitational waves from theory into reality but also gave us our first glimpse into the most violent and mysterious events in the universe. And in 2017, the three physicists were awarded the Nobel Prize in Physics for their groundbreaking achievement. Just think about it, a nearly undetectable wave, barely a ripple in the fabric of spacetime, had the power to validate centuries of physics theory, and even unlock new questions about black holes and the cosmos. The gravitational waves detected by LEGO came from the merger of two black holes, a cataclysmic event that occurred 1.3 billion years ago. These black holes collided, creating an enormous burst of energy that sent ripples through spacetime. And those ripples? They traveled across the entire universe, reaching Earth and being captured by LEGO's detectors. This wasn't just proof that black holes exist, it showed us how they shape the very fabric of spacetime itself. Kip and his team weren't just discovering gravitational waves, they were giving us a whole new way to understand black hole mergers, galaxy evolution, and the universe's biggest events. This breakthrough opened a new window into the universe, allowing us to hear cosmic events that were previously invisible to us. The detection of gravitational waves wasn't just a monumental achievement in physics, it was a milestone in our understanding of the universe. Through LEGO, we realized that every cataclysmic event in the cosmos leaves a trace in spacetime. And now, we can listen to those traces, those faint echoes of the past, that have traveled billions of years to reach us. Kip Thorne's work didn't just provide theoretical support for gravitational waves. He was instrumental in turning this theory into experimental science. His contributions have fundamentally changed how we understand the universe and opened up new tools for scientific exploration. But let's not forget that this discovery wasn't just about validating physics theories. It was also about showing us a whole new way to observe the universe. LEGO has given us a new way to explore the cosmos, a way that wasn't even possible before. Kip, Rainer, and Barry's achievements will be forever etched in the annals of physics. Thanks to their dedication, we're now entering a new age of discovery, one where gravitational waves and spacetime exploration will lead the way as we unlock even deeper mysteries of the universe. Fast forward to 2014, when the movie Interstellar hit theaters. Not only did it captivate audiences with its stunning visuals, but it also sparked widespread interest in black holes, wormholes, and even time travel. And behind it all? One man's name, Kip Thorne. Kip Thorne, already a superstar in the world of physics, became a movie star in 2014. Director Christopher Nolan had an unyielding vision for the science in his sci-fi masterpiece, but he knew that bringing a phenomenon like a black hole to life on screen required more than just special effects, it needed solid scientific grounding. So, Nolan turned to Kip. Their collaboration wasn't simple. The science that needed to be depicted was incredibly complex, topics like the event horizon of black holes, the formation of wormholes, and how to use these cosmic objects for interstellar travel. For the average viewer, these concepts were almost like an alien language. But Kip, with his decades of research, translated these mind-bending phenomena into visual representations that were not only accurate but also captivating. Perhaps the most impressive part of the movie was the depiction of the massive gargantua black hole. Kip and Nolan spent countless hours making sure that the black hole in the movie adhered to real-world physics. To achieve this, Kip reached out to Hollywood's top visual effects team, using simulations of light bending and event horizons to create the most scientifically accurate black hole ever seen on film. Can you imagine it? The black hole in Interstellar was calculated using Kip Thorne's mathematical models. The design of Gargantua was based on equations from general relativity and was modeled on supercomputers. What you saw on the screen wasn't just CGI, it was science and art coming together in the most stunning way. But Kip didn't just act as a scientific advisor, he also made an appearance in the movie itself. He didn't just lend his expertise, he helped provide real scientific insights into the film's depiction of spacetime travel. Time travel is one of the core concepts of the film. But, unlike other sci-fi movies, Interstellar didn't just throw out impossible ideas, it was grounded in rigorous science. Kip explored the idea of whether wormholes could really serve as shortcuts for interstellar travel, and whether humanity could, in reality, use them to cross vast distances in the universe. These theories were brought to life on screen, thanks to Kip's meticulous work. He took complex physics formulas and turned them into stunning visuals that brought the audience into a universe where science and imagination blended seamlessly. Though Interstellar is a science fiction movie, many of the concepts it explores are based on Kip Thorne's decades of research. The film opened the public's eyes to how cool science can be, and Kip Thorne went from being a physicist in a lab to a global science superstar. When the movie hit theaters, Kip's name was on everyone's lips. Some fans even joked that Kip was the true leading man of the movie. The success of Interstellar didn't just make black holes the hottest topic in science, it inspired a new generation to take an interest in physics and astronomy. Through Interstellar, Kip helped bring science to the big screen. He bridged the gap between reality and imagination, showing the world that physics isn't just for scientists in lab coats, it's a story waiting to be told. And through this film, Kip Thorne didn't just make science accessible, he made it exciting, showing us the vastness and mystery of the universe. Imagine this, everyone's talking about the black hole in Interstellar. But behind that black hole is Kip Thorne's research, his thinking, and his equations. Kip and the film team built a bridge between science and fiction, letting the world see the beauty and wonder of physics, and the power of imagination. Kip Thorne didn't just bring science into a movie, he brought the universe itself to life. And through Interstellar, he showed us that the most complex theories can lead to the most breathtaking discoveries. Kip Thorne's impact has always stretched far beyond the academic world. Sure, he's the father of gravitational waves, but he's also been a mentor to countless young scientists. Thanks to him, those with an insatiable curiosity about the cosmos and black holes found themselves walking the path of physics and astronomy. But what Kip gave them wasn't just scientific knowledge. No, he imparted something much more valuable: the way to think critically, the courage to solve problems, and the resilience to never back down. In the 1980s, Kip became a professor at Caltech. It wasn't just about lecturing for him. His classroom became a breeding ground for brilliant minds. His lectures were always filled with passion for science, often laced with humor that made even the toughest concepts accessible. His students didn't just learn physics, they learned to look at the world through a lens of innovation. Many of those students went on to become leaders in their fields. Some became astronomers, others pushed the boundaries of gravitational wave research, and every success they had can be traced back to Kip's influence. But Kip wasn't just an educator, he was a bridge builder in the world of academia. He maintained close academic dialogues with some of the brightest minds of his time, most notably with Stephen Hawking. Kip and Hawking shared a mutual passion for black holes, spacetime, and quantum gravity. Despite having different academic backgrounds and approaches to thought, the two often found common ground in their research, helping push the frontiers of physics. Kip's work on black hole entropy and radiation, building on Hawking's famous black hole information paradox, was crucial in supporting Hawking's theories on radiation. Kip always held great admiration for Hawking's work, and Hawking, in turn, consistently praised Kip's theoretical contributions. Kip's academic connections weren't limited to just Hawking. He worked closely with other scientific giants, including Edward Witten and Alfred Einstein. These collaborations weren't just about exchanging ideas, they helped drive forward some of the most cutting-edge research on black holes, with Kip standing at the helm. His growing influence in the global scientific community was undeniable. But Kip's reach didn't stop at the confines of academic research. He made it his mission to bring science to the wider world, helping bridge the gap between academia and the general public. His collaboration with director Christopher Nolan was a game-changer. Kip helped bring black holes, wormholes, and the bending of spacetime to life on the big screen in Interstellar. The success of the film sparked a global interest in the cosmos, time, and gravitational waves. And Interstellar did more than just make science cool, it showed the world that science could be an emotional, heart-thumping story. It could stir the human curiosity to explore the unknown. Through Interstellar, Kip Thorne's name wasn't just known among scientists, it became a household name for moviegoers. He was no longer the lab hermit, he was a science star. And he didn't just step into a movie set with his scientific expertise, he brought his smile and charisma with him, creating something that bridged both worlds. Kip's life has been filled with groundbreaking collaborations, spanning multiple fields. He used his science to inspire cinema, and through film, science reached a broader audience. With every new project, he continued to build connections between the world of academia and entertainment, using his influence to spread the love for science. And it didn't stop there. Kip's influence reached into the world of popular science writing. He published numerous books, but perhaps his most famous was Black Holes and Time Warps, which became an international bestseller. It wasn't just a book for science enthusiasts, it opened the doors of complex astronomy and physics to the everyday reader, making intricate concepts approachable and engaging. Through his books, lectures, and public speaking, Kip made the mysteries of the universe accessible to millions. He didn't just give us knowledge, he sparked a passion for science in the hearts of everyday people, helping science break free from the ivory tower and reach the masses. Kip Thorne wasn't just a physicist. He was a science ambassador. With humor, passion, and clarity, he made the most complex phenomena come alive. He didn't just teach us about black holes, he made us fall in love with them. He made physics exciting, inviting us to be part of the scientific exploration of the universe. But Kip didn't stop there. He collaborated with musicians, exploring the sound of gravitational waves. He worked with artists to create visual representations of the cosmos. He even engaged in deep philosophical discussions about the nature of time, space, and life itself. These cross-disciplinary collaborations didn't just amplify Kip's influence, they blurred the lines between science, art, philosophy, and entertainment. Kip's influence wasn't confined to one corner of the world. He became a global symbol of how science and culture can interact. He didn't just study black holes in a lab, he brought them to life on movie screens. And through this seamless fusion of science and art, he invited the entire world to join him in exploring the universe. But what really set Kip apart was his unshakable belief that science isn't meant to stay locked away in labs. It should be shared, discussed, and experienced by everyone. He used his life's work to show us that when science, art, philosophy, and entertainment collide, the possibilities are endless. Kip Thorne's contributions weren't just about gravitational waves and black holes. He revolutionized the way we perceive the universe, showing us that science is not just a set of equations on a chalkboard, it's the key to understanding the very fabric of reality. He made the complexities of physics understandable and inspiring. His work wasn't just about pushing the boundaries of physics, it was about making the wonders of the universe accessible to us all. From the first detection of gravitational waves to his explorations of the black hole information paradox, Kip's brilliance and determination brought once unimaginable phenomena within our reach. His research wasn't just about theoretical contributions, it was a gift to our collective curiosity. Yet Kip's journey didn't stop with the Nobel Prize. Even after achieving global recognition as one of the foremost scientific minds of our time, Kip continues to explore. He once said, "Science has no end. There's always a new ultimate black hole waiting to be discovered." His life has been one of perpetual exploration, his curiosity never satisfied. The future of science could very well be the stage where Kip writes the next chapter of his legacy. Who knows? The next major breakthrough might just emerge from the depths of his own quest, as he continues to lead us toward the frontiers of the unknown. The next big discovery could very well be hidden in the very fabric of spacetime that Kip is helping us to explore. Kip's journey is far from over. And who knows, maybe the next great scientific frontier is one we'll all walk through together, hand in hand with Kip Thorne, as he guides us to the next universe of scientific wonder. If you think black holes and gravitational waves are mind-blowing, just wait for Kip to take us to the next level. The universe isn't done revealing its secrets, and neither is Kip. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.